So we are moving on to the next unit. This is going to be all about quadratic equations. So these quadratic equations should hopefully look pretty similar because they're just polynomials written as equations, so they're equal to something. Okay, so a lot of these are going to be like trinomials, and they are written in this standard form. So we've got standard form, and here it is. Y equals ax squared plus bx plus c. So this is a trinomial. This is something we've seen before. The only thing that's new is now we're saying it's equal to y. Okay, so this is the only new thing. And this is what we call standard form. So when we're graphing a quadratic equation, it creates a U-shaped curve, and we call this a parabola. So it's not going to create a straight line. It's going to look something like that, or maybe something like this. So it's not a linear equation, it's a quadratic equation. So there's a couple types of parabolas. So when we're graphing our equations, we can see these in our calculator. So you're going to want to have your calculator here. I'm going to quit out of this app. And anytime I want to graph, I need to go to y equals. So y equals, clear out whatever's there already. Okay, and make sure that any of these plots are turned off. To turn them on and off, you just scroll over to them and hit enter. Notice now this plot is turned on because it's highlighted. To turn it off, I just highlight over it, hit enter again, and it should now be ready to go. Awesome. All right, so let's go ahead and graph this first one. So we have x squared, so x squared plus 2x minus 5. All right, let's make sure it matches up, x squared plus 2x minus 5, and let's hit graph. So our graphs might look slightly different. My window is kind of shifted. So standard window is a minimum of 10, maximum of 10, and a scale of 1. So if you want, you can just kind of change that, negative 10, 10, 1, and we can go back to our graph. It's going to center my graph like that. Awesome. So we're just going to sketch the following graph. So something that we should note is that it's kind of shaped like this. Right? And we might not know the specific point, so we can just kind of sketch it right now. There's a couple things I want to point out to us on this graph. Okay, so the lowest point of the graph, so in this case our graph opens upwards, it's got this like dip. The lowest point of that is called the vertex. So that's our vertex. And then along or through that vertex, there's this imaginary line that cuts the graph in half, okay? So it kind of breaks it into one side and another side. And we call this the axis of symmetry. So this is the axis of symmetry. Because our graph is symmetric on the left and on the right. Now our graph, or our sketch, is probably not very perfect, but if you look at our picture, the left and the right side are pretty much equal. Okay. Now it's not centered directly on the y-axis, and that's okay, but there's still an axis of symmetry going through that. All right, so let's look at how this other one looks. Okay, so we're moving on to the next example. We're going to go back to y equals, clear out that, and let's plug in what we have now, negative x. So be careful that you're using the negative button and not the subtraction. See how those two look different? If you use the subtraction, it's going to give you a syntax error. So we have negative x squared plus 3x, that's not right, plus, negative x squared plus 3x plus 7. Okay, I'm going to check and make sure that my calculator and my paper look the same. Okay, ready to go. Let's graph that. It might take a second. All right, so it looks like this graph is totally different shape. So this, instead of it going kind of looping the other way, it's actually starting from the bottom, moving up, 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 and then coming back down. So if we're going to sketch this graph, we might say it looks something like this. And this is just a sketch, nothing perfect, just given the idea of where it is and how it's oriented on the graph. So remember how the vertex was the lowest point of the graph on the left? The vertex here is going to be the highest point. So it's wherever the graph starts to change direction. So this is our vertex. And Also through this, we have an axis of symmetry. Okay, so it's a line, an invisible line that divides the graph into two equal parts. So axis of symmetry. Awesome. So there's a couple things that are different between our two graphs. First thing we should notice is that this has a positive x squared. So this is a positive graph. So if a is positive, a meaning the coefficient in front of x squared, so that comes from this a right here, the coefficient in front of x squared. So if the number in front of x is positive, which in this case it's just positive 1, then the parabola opens upwards. It opens up to the sky. So it's kind of like a smile. So it's positive, it's happy, it's got a smiley face, looking like that. Okay, so this is our positive graph. Positive, positive. And then in contrast, this guy, he's got a negative in front of the x squared. It's got a negative coefficient, so a negative a. If a is negative, then the parabola opens downwards. Kind of like a frown. So we can think if someone's being positive, they're smiling, the graph looks like a smile. If someone's being negative, they're frowning, looks like a frown. So there's our positive and negative graphs. So we've labeled the axis of symmetry, but let's be sure that we make sure we understand what exactly it is. So the axis of symmetry, it's a vertical line. The vertical line that divides the parabola into two equal parts. Into two equal parts. Okay, so remember our axis of symmetry in our pictures is that line that goes through the vertex. It's a vertical line and it cuts it in half. So the left side is the same as the right side. It's equal parts. So there's a formula for us to find the axis of symmetry, okay, or at least to find the x value for the axis of symmetry. So the x value meaning on the graph, where is the x value, or the line is an x equals line because it's a vertical line. So here is the formula. X equals negative b over 2a. So let's think about a, b, like what are these a and b coming from? Where are they coming from? They're coming from standard form. So negative b would be negative whatever this b term is. A is the term with the first, it's the coefficient with the term that's squared. So whatever those numbers are, you're going to plug it into this formula. X equals negative b over 2a. And so it's a line written as x equals something. Think back to that, remember we talked about Hoyvux? So Hoyvux says that vertical lines are written as x equals. That's why it's written as x equals. Okay, so we've talked about the axis of symmetry. Let's talk about the next thing that we labeled, that is the vertex. So the vertex is either on our graph, it's either the lowest point on the graph or the highest point on the graph. So there's two things we might call them, okay? So when the vertex is the lowest point on the graph, like in this first example, we call it a minimum. Because it's in fact the lowest point on the graph, it's the minimum. When the vertex is the highest point on the graph, like in this example, instead we're going to call that the maximum because it's the maximum height. It's the maximum y value that the graph reaches. And the vertex, it's just a point, it's not a line. It's the turning point of the parabola, so it's when the graph starts to change direction. The turning point of the parabola. Okay. And I'm going to put a box around this axis of symmetry formula because this is really, really important. This is something that we need to remember. Okay, so using all of this information, let's go ahead and complete some examples. So I'm going to scroll this out a little bit so we can see a little bit more. We're going to use this information to find the axis of symmetry, the vertex, and then draw a little sketch. Okay. So here's our example, y equals x squared plus 8x plus 15. So remember our standard form is y equals ax squared plus bx plus c. So our a is with this, our b is with this term, and our c is this final value. Okay. So our a, what is our a in this example? Our leading coefficient is just 1, so a is 1. B is a positive 8, and C is a positive 15. Okay, so to find the axis of symmetry, we're going to use our formula. There's our axis of symmetry formula. X equals negative B over 2A, and we'll plug in what we know. Negative B, so negative 8 over 2 times 1. Well, that becomes x equals negative 8 over 2. X equals negative 4, and that's how we write that line. X equals negative 4. Okay. We're going to use this to then find the vertex. All right, so once you have the axis of symmetry, that's the x value that the vertex is located. Okay, so we're going to take our original function, our quadratic function, and we're going to plug in negative 4 for x. So it'll look something like this. It'll say y equals, instead of x squared, we're going to take this x value, negative 4. So we're going to say negative 4 squared plus 8 times negative 4, there's our 8x, plus 15. And we'll solve this out. 16 minus 32 plus 15. So check that, see what you get. And we should get y equals negative 1. Now, how should we write our vertex? Is the vertex a y equals something? No, the vertex is a point, okay? So it's an x and a y. It's an actual ordered pair. And that comes from the x of the axis of symmetry, so it's going to be that negative 4. And the y value is what we just found, negative 1. And we can make a sketch of this graph. Let's go ahead and graph it in our calculator. So let's clear this out. We've got x squared plus 8x plus 15. So our graph is opening upwards, and that makes sense because it's a positive value in front of x. So if we're going to draw a sketch of it, let's say we have this. It looks something like that. Doesn't have to be perfect, just it's going below the x-axis and it's opening upward. All right, we'll do one more example together on the next page, number 2. Let's identify A. A is negative 1. B is positive 10. And C is negative 23. Okay. Our axis of symmetry comes from that formula, x equals negative b over 2a. So we'll plug in what we've got. X equals negative b, so negative 10, over 2 times negative 1. So x equals negative 10 over negative 2. Simplify that, x equals 5. X equals 5. Okay. Then we're going to use this to find the vertex. So for the vertex, we take our formula and we plug in the x value to find that out. So pause, do your work, and then check back in a moment when you're done. So check your work. We plugged in our 5 for x. You get that y is 2. So our vertex is at 5, 2, and the graph is going to look something like this. So for sketching, it opens downward, which makes sense because it's a negative graph. All right, good luck with the rest of your practice. Make sure you ask questions if you have them.